So in today's lesson, we are going to look at multiplying a polynomial by a monomial. So this is lesson number 2. We are going to look at using algebra tiles as well as using symbols in order to complete these multiplications. So again, a review from the last day. If my tiles are shaded, they're positive. If they are unshaded, they are negative. So if I was to complete these diagrams to determine the product, I have an x rod being multiplied by 1. Anytime I multiply something by 1, it doesn't change. And if I look at filling this in terms of length by width, I get another rod, which I would then shade in. Again, length by width. And that gives me another rod, length by width, and I end up with a small square, and another length by width, and I end up with a small square. So all together, I have 2 of these rods, which means 2 of those x's, and I have 2 of my 1's. So that becomes the product of the monomial with the polynomial. If I look at B, length times width, this time I get an x squared tile that again is shaded. Length times width, or width times length. And these are all shaded. So when I expand this out or remove the brackets, I have an x squared and 3x tiles. So what you can do at this point is pause for a couple of minutes and complete C, D, and E on your own, and then when you're ready you can press play and we can work through them, or you can see how I work through each of them. So C is a bit different because now I have these negative tiles. So again, I still have the length and the width, so I still get a rod, but a positive and a negative is going to give me a negative, so I wouldn't color it in. So the same thing would happen with these 2, so I end up with 2 more rods. Length and width, I end up with a square, but the 2 negatives make a positive. 2 negatives make a positive. So in the end, I end up with 3 rods, which would be a negative 3x, and 3 positives, or 3 positive 1s, so I'd end up with a positive 3. In D, there's my length and the width. Because they're both positive, my answer would be positive. Answer is positive. Now I have this width by this length, which is going to be negative. A negative and a positive will give me a negative answer. So I have 2 positive x squareds and 4 negative x rods. The last one, x minus 1 times 2 x's. So I end up with this square that is positive. I have another square that is positive. I end up with a rod that's going to be negative because of the positive and the negative, and another rod that's negative. So I get 2 of those x squareds and 2 of those negative x rods. Now, using algebra tiles is a useful method. However, it can start to become very restrictive. And if the numbers start to become large, it's going to take me a lot longer to do this. So we introduce an algebraic concept, not on the next page, but the page after, called the distributive property. If I ask you to distribute a stack of papers you're going to give a piece of paper to everybody in the class. The distributive property is kind of like that. I take the thing that's on the outside and I distribute it to everything inside. And to distribute it means to multiply it. So if we go back from the previous page, that's what these 5 were. This 2 times x plus 1, because that's the operation between the brackets, means I would take the 2 and multiply it by the x, and the 2 and multiply it by the 1. If I look at the next one, take the x and multiply it by the x. Exponent rules would tell me that the exponents would be added. 1 plus 1 would equal 2. So there's my x squared, not just the length and the width. And then x times 3, 3x. 2x times x, I get 2x squared. 2x and negative 2, there's my negative 4x. If I take a negative 3 and multiply it by x, I get a negative 3x. And when I take my negative 3 and multiply it by negative 1, I get a positive 3. And in the last one, it's just flipped around. Means that I take each of these terms and distribute it to that one. So I take an x, multiply it by 2x, take a negative 1, and multiply it by 2x. Remember, order doesn't matter when I multiply. It doesn't matter if I go 2 times x plus 1 or x plus 1 times 2. I'm going to get 2x plus 2 either way. So the distributive property can be written like this. B plus C, or sorry, we'll start with this one. A times B plus C means I take A and I multiply it by B, and I take A and I multiply it by C. Or if I reverse it, B plus C times A means I take B and I multiply it by A, and take C and multiply it by A. And then if I want, I could put these in alphabetical order, and there's my AB and my AC. So what I want you to try to do is press pause and try to do these 4 class examples on your own. Once you've done them, you can press play again, and then we can go through them together. So if I take the 4 and multiply it by 3x, there's 12x. 4 times 1, positive 4. In the next example, I have a negative 5 times 2x squared, negative 10x squared. Negative 5 times x, negative 5x, negative 5 times negative 6, and there's my positive 30. In C, take the x cubed and multiply it by the x squared. My exponent law says the bases are the same. I add the exponents, so I'm going to get x to the power of 5. Then if I take negative 2 and multiply it by x squared, I get negative 2x squared. The last one, take negative 3x and multiply it with each of these terms. So I get negative 21, the negative 3 times 7. X and x will give me x squared. Negative 3 times negative 2 will give me a positive 6. And then I have an xy. Negative 3 times what would be a 1 would give me negative 3 xz. So in the example above, we've written a product of polynomials as a sum or difference of terms. In this process, we expand it. So the word that we use, or that you'll see a lot, says expand the following expressions by using the distributive property. So we use the distributive property, and we also use the idea of the exponent rules. Bases are the same, and I'm multiplying, I add the exponents. So with class example number 4, we just have 2 parts to it. So what I'll do is I'll do B as an example, and then you can wait a couple or try to do A and C on your own, and the same process again. So if I look at B, think of it as being 2 separate parts. So the 4 gets distributed to these 2 these 2 terms. 4 times 2x, I get 8x. 4 times negative 3 gives me negative 12. In this one, I have a negative 2. So the sign that's in front, keep it as making that coefficient or this value here as positive or negative. So I'm going to take this -2 and multiply it by x. I get a -2x. Take the -2 and multiply it by 6, and I get a positive 12. From here, I would collect my like terms. 8x minus 2x minus 12 plus 12. So 8x minus 2x would give me 6 x's, and a -12 and a positive 12 would equal 0. Again, pause. When you're ready, press play and look at the next two examples. So in class example number 6, or in A, I have two parts. I have this 6, and then I have this -4 times 8x plus 1. So the 6 isn't being multiplied by anything, so it's going to stay the same. The -4 I multiply by 8x, and I get -32x. Then I take the -4 and multiply it by 1, and I get a -4. Go to collect the like terms. It's going to be 6 minus 4, which gives me 2, minus 32x. Then if I look at the last one, I start off by taking 5x and multiplying it by everything in this trinomial. So 5x and 3x squared, I get 15x cubed. 5x and -7x, 35, or -35x squared, and a 5x times 1 would give me 5x. This negative times 4x minus plus 3x squared, think of it as being a -1. If I take -1 and multiply it by 4x, I get -4x. -1 times 3x squared, -3x squared. So I collect my like terms. 15x cubed minus 35x squared minus 3x squared plus 5x minus 4x. So my final answer would be 15x cubed minus 38x squared plus 1x. So the last class example asks to calculate the area of each shape. So these are odd shapes. We need to make them into shapes that we can work with. So in the first one, we're given the hint, break this up into 2 rectangles. So if I was to break this up into 2 rectangles, I could go across this way or I could go this way. Doesn't matter which one you pick. I'm going to go across horizontally simply because when I look at this 3x plus 2 and this x plus 5 are a little bit more complex than figuring out if this is 2x and this is 4x, what would this have to be? So it'd have to be something that when I go 2x plus something, I get 4x. So if I have 2x's, what do I have to add to it to get 4x? I add another 2x. So the area would be the area of part 1 plus the area of part 2. So the area of part 1 is my 2x times 3x plus 2. And then I'm going to add 2x times x plus 5. So I expand this out by removing the brackets. I use the distributive property, 2x and 3x, 6x squared, 2x times 2, 4x. Put the positive in front, so we think of this as a positive 2x times x. It's 2x squared again. 2x and 5 is 10x. Collect my like terms. With my x squareds, I have 6 So I have 8 of those x squareds. My x's, I have a 4 and a 10, which gives me 14. In part 2, we're asked to subtract the area of the two rectangles. So with subtraction, what I'm going to look at is I'm going to say, well, what if I had this? Then I could look at it as this large rectangle that measures 3x plus 2 by 4x. And then I'm going to subtract this shaded part in here. Now we already know that this is a 2x. What I need to determine is what is the width of this part. Well, it's going to be this 3x plus 2 minus this x plus 5. Because that'll give me what's left over. X plus 5 plus what will give me 3x plus 2. So 3x minus x, I'll be left with 2 of those x's. 2 minus 5, negative 3. 2x and x is 3 x's. Negative 3 and 5 is 2. So then I will take 2x and multiply it by 2x minus 3. And I'm going to subtract that value. So this part here, I remove the brackets. 12x squared and an 8x. Think of this as being a negative 2. So then I get negative 4x squared. Negative 2x and negative 3 gives me a positive 6x. If I have 12x squareds and I take 4x squareds away, I'm left with 8x squared. If I have 8 x's and I add 6 more, I will have 14 of them. So I get the same answer, just 2 different methods. So the questions that I want you to work on for this class are question 4, A, F, and J, 5, A, and E, 6, A, and C, 7, A, and D, 8, A, and 9, 10, and 11. So you'll work on this for about 20 minutes, and then I want you looking at lesson number 3, multiplying binomials.